Hey folks, welcome to this webinar. This is data modeling with MongoDB. Give it a moment for folks to join. When I start to see participants coming in, oh my goodness, yep, we've got quite a few coming in. It's great to have you. My name is Michael Lynn, and today we'll be talking about data modeling with MongoDB and how that differs from traditional relational databases. So as you come in, we'll give it another couple of seconds before we kick off the presentation. Keep in mind, this is going to be recorded. You'll be receiving a link to the recording on Friday. While you're coming in, I also want to point out that there's a chat box and a Q&A box. We want to make sure we differentiate between these two. If you have questions about the content, use the Q&A panel. Don't use the chat panel for that because your questions are get lost. But while you're in the chat panel, hey, let me know where you're from. I'm talking to you from the East Coast of the United States, just outside Philadelphia. Where are y'all from? I'd love to hear you guys chime in the chat box. Let me know where you're from. Also, maybe while you're doing that, let me know what your level of expertise is with MongoDB. How familiar are you with MongoDB? Are you a beginner? Are you an intermediate? Are you advanced? That'll help me gauge kind of where we go with the content. All right, it's approaching 1 after. Already getting some questions. Looks like the chat may be disabled. Is that the case? We want to make sure we enable the chat for folks so they can chime in, let us know where they're from. I don't know if we can do that live while we're doing that, but awesome to see you guys chiming in the Q&A. That's great. Oh, wow, yeah. So from Mexico, welcome. Toronto. Yeah, chat is still disabled. Sorry about that, folks. There we go. It's enabled. San Diego. Myanmar. Wow. Oh, my goodness. You guys are killing it. I love it. 300 so far. Man, it is good to see you guys piling in. Once again, my name is Michael Lynn. I'm a developer advocate at MongoDB, and I'm so thrilled that you've joined me today. I hope I'm going to be able to answer all your questions about MongoDB and data modeling. I've got some folks helping out. We've got Diego. He's on the developer advocacy team too. He's going to be helping out answering questions. Make sure you put those in the Q&A rather than the chat. I've got Cedric Clyburn. He's an intern this summer. Welcome, Cedric. He's going to be helping out. And we've got my boss. Say good things and stick around for the poll afterwards. My boss, Joe Drumgoole, is on as well. He's going to be helping answering questions. So outstanding. I think we've given enough time for folks to join. Let's get kicked off. We do have a podcast, by the way. That's my voice you hear on that podcast. The latest episode is 118. It's with Uncork. So if you're interested in learning how to code without coding, there's a great episode there. And you can get to that podcast on all of your podcast networks or visit mongodb.com/podcast. And I hope you will subscribe, like, leave a comment, all those good things. Great content there. Continue your journey of discovery about MongoDB with the MongoDB podcast, mongodb.com/podcast. Also follow me on Twitter @mlin. I talk about MongoDB. That's pretty much it on Twitter. So hope to see you there. You can follow me on Twitter. Some housekeeping. As I mentioned, this webinar will be recorded. So if you have questions about whether or not it's going to be recorded, hang tight. You'll get a URL for the recording on Friday. You are going to be muted. You won't be able to talk to me, but you can use the Q&A box to ask questions. Make sure you don't lose your questions in the chat box. Make sure you put your questions in the Q&A. Also, as we get close to the end, stick around, please. It's going to be a huge favor for me if you stick around and answer the questions in the survey. Take a poll, and it's going to help us improve so we continue to give you great content and always improving. Today's agenda. Document data modeling. We're going to look at data modeling with MongoDB, the document data model. We're going to look at MongoDB Compass, which is the UI for MongoDB. It runs on your desktop or your laptop. We're going to look at the process of modeling data. What does that look like, and how is it different in MongoDB? And we're going to also look at some design patterns and some anti-patterns. What are some good things to do? What are some not so great things to do? And how can you improve? And then I'm going to show you how to to get some advice from MongoDB Atlas in the Schema Advisor, built right into Atlas, our MongoDB database in the cloud. If you leave today with one thing, if you leave today with this one thing in mind, this mantra, I will have succeeded in my job. That mantra is data that is accessed together should be stored together. Keep that in mind. It's going to make more sense as we go forward. I want you to say it, though, in your mind together. Data that is accessed together should be stored together. Okay? So imagine it's 1970. You may not have been born yet. I was. I was just a couple years old in 1970. But people looked like this back then. They dressed kind of funny. But there was this one guy, and his name was Edgar Cod. Edgar Cod worked at a company called MongoDB. No, not MongoDB. He didn't work at MongoDB. He worked at IBM. MongoDB didn't exist in the 70s. So he worked at IBM. IBM makes computers. They look like this way back then. And they had disk drives inside of them that looked like this. Crazy, right? That's where the data was stored. And these things were expensive. Super expensive. How much? Really, really expensive. To the tune of for 1 megabyte of data, it was $9,200 back in those days. $9,200 to store 1 megabyte of data. That's kind of phenomenal. So if you think about this guy, Edgar Cod, he's working at IBM, and these computers are catching on, and he's concerned about how much money it's costing to store this data. And he comes up with this plan. He's like, well, if we can minimize the amount of times we duplicate data as we store it, we're going to save money. People are going to enjoy using computers much more if they save money, right? And that became Cod's rules of normalization. This is how we normalize data in relational databases. You create the schema, and you normalize your data by dividing it into multiple tables. Well, a funny thing happened along the way to 2007. The cost of producing those hard drives dramatically drops. It goes from about $9,200 to like nothing, next to nothing, all the way from 92 all the way down to 0.0002 cents per megabyte. So the rules that were created by Cod to store this data so that it maximized the efficiency of disk storage kind of don't make sense anymore. And if you think about it, in the real world, it doesn't really match the way that we store data in the real world anyway. If you think about storing data in the same way that you store data in a relational database, maybe storing a car in a garage, you wouldn't separate it into separate buckets. You wouldn't have a tires table and a seats table and an engines table. You want to store the car all in one place, right? That is our mantra. Data that is accessed together should be stored together. That's kind of the idea. So again, getting back to our mantra. So this does represent a shift in thinking. Now, if you're developing an application and you're not used to this, you're going to have to change your mindset just a little bit. You may be used to thinking about your schema first and then developing your application. But with MongoDB, we can store all the same data elements, but they're stored in a little bit different way. They're stored in this JSON-like structure. JSON's nothing to be afraid of. It's an object. JSON is key value pairs, and you can see them here. Those in green on the left, they're keys, and then there's the values. And we're going to go into detail what those key value pairs look like and what the capabilities are. But I want to transition shortly, briefly, to MongoDB Atlas. If you're playing along at home, you want to do this, you want to look at some of this data, it's super easy to do. You can create an account at cloud.mongodb.com. If you don't have an account now, it's probably going to take you too long. It's going to distract you for a bit, but you'll get this recording. Remember, you can go to cloud.mongodb.com and register. We're going to be using a sample data set. We've thought ahead. And we've thought of all the things that you're going to need to have at your disposal in order to get effective really quickly. We've even created sample data for you. So you can launch a cluster. Once the cluster comes up, you can deploy a sample data set, and that's what we're going to work with today. The sample data set is called mflix, sample_mflix. And I'm going to show you what that looks like. I'm also going to show you how dead simple it is to launch a new cluster in Atlas. Once you're logged in, I've already got this cluster deployed, but it's as simple as clicking Create, selecting your cluster type. For now, we're going to focus on the shared type. It's going to be the free forever instance. in MongoDB Atlas. You don't have to pull out a credit card. It is free forever, folks. You don't really have to pay for it. Even if you launch a production app on it, I wouldn't recommend it because it's going to be relatively low in the amount of CPU and the amount of disk that you have, but it's certainly available for you to do with whatever you like. Once you select the shared type, then you select the cloud provider. Notice we support AWS, Google Cloud, and Microsoft Azure. These are our partners, and this is where we deploy the MongoDB instances into. Atlas is an application that runs above the cloud provider. So if you have your applications running in Google Cloud, you may want to deploy your MongoDB instances in Google Cloud, AWS, Azure, etc. Notice as I change the cloud provider, the regions change. That's because those cloud providers have data centers in different regions. Let's stick with AWS for now. I'm on the East Coast of the United States, so I'm going to select North Virginia. And from there, I'm going to select the M0 sandbox. That's the free instance. You can always choose larger instances. It's going to give you more memory, more CPU. But for now, let's stick with the free tier. And I'm going to leave backup off for now. And then I'm going to change the name of the cluster instance. I'll call it July Webinar. Once I click Create, it's going to take about 7 minutes, and I'm going to have a cluster available to me. From there, I'm going to need to give you some access. So I'm going to go into Database Access, and I'm going to create a database user. There's several methods that you can use to authenticate your users to have access to your data. Password authentication is probably the simplest. Mike and password 123. And then from there, I'll add that user. And then once I have database access created, I'll want to poke a hole in the firewall so that I can access this database from my laptop. I'm going to be accessing it using MongoDB Compass, for example, from my laptop. So I want to make sure I have an IP address that is in the firewall rule set. And or I could just say allow access from anywhere. That's a little less secure, but I can do that for now. And once I do that, those changes are going to be deployed to my cluster. And once that's in place, we can take a look at deploying our sample data set. Super simple. I select load sample data set. It's going to notify me that it's about 350 megabytes. I click load, and away it goes. Once it's complete, you'll be able to click the Browse Collections button and see. Here we have all of our databases. And the one we're going to focus on today, time and again, we're going to be looking at the sample_mflix database and the movies collection. Okay, we're going to talk about modeling data through the lens of an application that maybe looks like a lot like Netflix, for example, where you're wanting to watch movies over the internet, and maybe that's what the application looks like. This looks a lot like that database, what that database might look like. And in this Browse Collections tab, here I can actually insert documents, I can modify documents, I can edit them, I can view all of these documents, and that's the data set we're going to work with. Okay, so that is MongoDB Atlas and the sample data set. I do want to transition back to the presentation for a moment, and let's take a closer look at those documents that we're going to be working with today. Now, I mentioned that there are key value pairs. The keys are always going to be strings. You're essentially describing what the value is. So you're going to do that with a string. Here we have ID, title, year, plot. The values are going to be interesting in that they don't have to just be strings. They can actually be document types or data types. They can be integers, as in the case of a year. They can be strings. They can be interesting data types like arrays. Look at this countries. Here we have an array that's indicated by the left bracket and the right bracket with elements in that array that are strings. It also can get pretty interesting when you have objects within objects. So this is a document. You can have a document within a document. So in the ratings field, we have a document which has key value pairs within it. That's where it gets really interesting. And that's where we begin to look at this concept of embedding. We're going to use the terms embedding and referencing throughout today's talk, and I'll explain a little bit further what those mean as we continue. So let's briefly take a look at MongoDB Compass. Now this is the UI. It's going to give you a lot of the same functionality that I showed you in MongoDB Atlas's data browser. Here I'm logged into Compass. I've provided the user access credentials that I created in Atlas, and I've logged in. Here are the list of my databases, and here's my sample mflix database. Let me see if I can make that a little bigger. Is that better? Everybody see that okay? Thumbs up maybe? Okay, so sample underscore mflix, and here are my collections. Here's the movies collection, and here are those documents once again. And here I can edit this document, and this is right on my laptop. And once I hit update, it's going to push those changes to the MongoDB Atlas cluster and store those in MongoDB. Okay, so this is how you can modify. You can also use the aggregation builder. What is an aggregation? Well, when you access MongoDB, you're going to be sending queries, and the queries can be in the form of an aggregation pipeline. This is how you get really the same functionality that you have in the relational world using SQL statements. You can do so with aggregations. And I think I've got one saved here. My queries. Yeah, here I've created this aggregation, which takes a look at the schema of the documents in MongoDB, and this is how you specify a filtered query. I'm going to match all of the documents in MongoDB with the year field greater than or equal to 2010, and this is a list of all those documents that match that. All these documents match the year field greater than 2010, and then this is where the pipeline concept comes in. I'm going to send all of those values to the next stage in the pipeline, and I'm going to match again, and I'm going to match the Metacritic field. The value must be greater than 90. So I'm looking for movies from 2010 that have a Metacritic rating of greater than 90. So you could kind of name this like maybe good movies from 2010. That's the aggregation pipeline, and MongoDB Compass is wonderful at assisting you in creating all of these, what can be, conceptually quite complex. It kind of simplifies it in that it lets you add stages and modify your queries there. That's one of the benefits of MongoDB Compass. Schema Analyzer is wonderful in that it will take a look at the documents as they exist in your database, and it will display each field in a logical way that humans like to look at. So it takes a look at the Metacritic field, for example, and it says this is a range of data values. And we know that humans prefer to look at ranges in terms of a bar chart. So here we have a bar chart representing all of the values in my database. And it did that by looking at a sample of the data. So that's the schema analyzer. Indexes work in MongoDB the very same way that they work in relational databases. They basically give you hints so that you can access the data faster. You want to be careful about creating your indexes because they do cost in terms of write performance. So when you create an index and you write data into your database, you need to update that index. So you don't want to just create superfluous indexes. You want to make sure you create them in line. And I'm going to show you the secret to ensuring that you're not creating indexes that you don't need. I'm going to save that for later. That's a spoiler. It's coming up. There's also the ability to create rule sets. So if you're like me, when I first started learning about MongoDB and this concept of polymorphism, like from one document to the next, I can have a different set of keys. What? That's crazy. What's going to prevent us from having like garbage in our documents? Well, that's where JSON schema validation comes in. You have the ability to restrict the types of data that get into your document. And you can do that right through this wonderful visual editor. I'm kind of running a little behind, so if you have questions about that, we can go a little bit deeper as we get further along. So that is MongoDB Compass, and highly encourage you to head on over to MongoDB Downloads and download Compass. Take a look at that. These are your documents that we just went through. Now, if you're new to MongoDB and you're developing an application and you're used to like focusing on your schema first, you can do that. It's going to help you in the long run. You don't have to create a rigid schema in the same way that you do with relational databases. But you're going to want to look at what your app is going to do with the data. Describe the workload. It always helps me to understand what my application is going to do in terms of the data. How many users are going to be, do I expect out of the gate to be interacting with my data, with my application? And what data types are they going to be supplying? How am I going to be updating it? That's how you describe your workload. Next, look at that data. Identify the data elements. If we're developing a movie application, what elements of data are there? We're going to look at that closer. Model the relationships between those data. So we're going to look closer at that again coming up. You're going to want to look at tooling. Now, you have some options. You can, with MongoDB, you can use a driver. There are drivers for all modern languages, Python, JavaScript, React. You can use a driver, or you can use an API. The MongoDB Atlas Data API exposes your data, and you can use an API first model for developing. So look at how you're going to interact with your data there. How is your end user going to interact with your application? And look at proven patterns for developing your schemas. We're going to go into that. Speaking of modeling relationships, MongoDB has a flexible document data model. That means that from one document to the next, it can take on different shapes. As you change the schema, the key value pairs that you store in your database, you can simply modify. You can add additional keys. And once you do that, once you modify your application to write additional keys and values, from there on out, those documents will contain those key value pairs. The previous ones will be untouched. There's going to be a test on this later. So hope you're paying attention. Documents support an embedded data model. Embedding versus referencing. Embedding versus referencing. Embedding is where you store all of the data that's going to be accessed together in the same place, in the same document. You can use arrays to do that. You can use straight key values. We're going to look at that closer. Normalization. It's a concept that COD developed. It can be accomplished in MongoDB, and we can do that through database references, just as you did with Postgres, MySQL, Oracle, your legacy relational databases. You can achieve the same type of referencing. I'm going to show you how to do that. When it comes to modeling your relationships, the key takeaway is what? It's our mantra. Data that is accessed together should be stored together. And lastly, focus on how your application will be using data. This is key because the whole premise here, folks, is that you're focusing on how your application and your users are going to interact rather than applying strict rules for how you normalize your data. Once more, I hope this is sinking in. Data that is accessed together should be stored together. Let's talk about modeling relationships. And there are several types of common patterns of relationships between data. You have the standard one-to-one. For every movie, there's a title. There's one-to-many. For every movie, there are many cast members. And for a many-to-many relationship, for every movie, there are multiple locations where the movies are shot. And many movies may be shot in many locations. It's a many-to-many relationship. So, let's look at the data elements in our sample data. Okay, here we have, maybe this is a movie in our application, The Lord of the Rings, The Fellowship of the Ring. Every movie has a title. Every movie has a rating. It's got a runtime, how long it is. It's got genres that it belongs to. Director, might have more than one director, by the way. It's got multiple writers, perhaps, and multiple cast members. Now, let's talk about the relationships between those elements. And if we're writing an application to manage this data, what's that going to look like? How are we going to model those one-to-one relationships? Well, in the relational world, when you're developing this application, you may be forced into thinking that you have to have multiple tables. One for the movies, just the straight movie data, and then for the details associated with that. And that's fine. That's fine. You can absolutely do that. And even in MongoDB, you can have multiple collections. Notice we don't call them tables, we call them collections. They're collections of documents. And we can have multiple collections or multiple documents in multiple collections, one for the movies collection and one for the movie details. This is interesting, folks, because here we go. Look at the object ID for the movie ID in the movie details collection. This is how we reference. If you want to do that in MongoDB, you can. But I would suggest that you take a look at the way that your application is accessing those pieces of data. If they're accessed together, store them together, folks. It's going to be much more efficient. And this is what it looks like when you embed versus reference. So we've collapsed those two. We've embedded the details into one single document. This is going to be much more efficient. It's a single read. So it's physics, folks. You're pulling data down a pipeline. If you're making one trip versus two, it's going to be more efficient. So let's look at one-to-many relationships. For every movie, there's going to be multiple cast members. Now, in the relational world, this is what it looks like. And yeah, sure, there are ERDs that support MongoDB. I see the question in the chat. You're going to want to put your questions in the Q&A box, not the chat. But there are ERDs that support. ERD is entity relationship diagramming. Schema on read, that's a concept that you'll need to get used to with MongoDB. The schema does exist. It's not something that exists separately. So if you're looking at something like an ERD, it will have to pull the data to look at what the schema looks like. Hope that answered your question. So one-to-many relationships. Movie table to cast members. And this is what it looked like in the relational world. And you can support that with MongoDB. Here we go. We've got a movies collection and a casts member collection. So notice the curly braces indicate that those are different documents. So we've got one document in the movies collection, and we've got multiple documents in the cast collection. Okay? So we're using back referencing. Notice the movie _ID key in the cast collection. That's a back reference to the movies collection. That works. You could do that with MongoDB. But I would suggest that if you're always accessing cast members in the same space that you're accessing that title, maybe you want to consider embedding versus referencing. And this is a different way. Notice we've got a cast key in our movies collection in this embedded model. This is where we have an array of cast members. So we have an array of documents in the cast key, cast field, I guess you could call it. And this is going to be much more efficient. Now, there are some cautions I'm going to have for you. You do not want to have an unbounded array. Now, cast members is probably something that's going to be fairly limited, but you want to look at your data elements and make sure that you're not just creating an array of unbounded, like you're going to want to bound that array somehow in your application so that you're not having thousands and thousands of array elements. That's going to be inefficient. Now let's look at modeling many-to-many relationships. In the case that I mentioned before, you've got movies that are shot on location, and locations can have many movies shot at them. So many locations, many movies, many movie locations. And you can support the same way of laying out data in MongoDB. You have a movies collection and a locations collection. The movies collection has an array of filming locations, which points to the locations collection. So that's one way of doing it. And then, of course, you're going to back reference from the locations collection to the movies collection. This is how you define your many-to-many. One way you may want to look at laying your data out differently in your application rather than doing multiple collections, embedding. Once again, embedding in your movies collection, you can have a filming locations and store the top filming locations in that document. So once again, we've got embedding versus referencing. Check on my time. Here we go. Okay. So when you're embedding, you're going to get a single query retrieving all of the data that you theoretically need. You've got a single operation to delete the data, which is much more efficient. You are not having data duplication well, it's one thing to watch out is data duplication, and watching out for large documents. If you're embedding, you do run the risk of having these massively large documents, and you're going to want to weigh the benefits versus the cost associated with that. When you reference data, you're alleviating duplication. You're going to want to look at why you're doing that, but it typically leads to smaller documents, and you will need to use joins in order to rejoin that data in your applications. So the dollar lookup is effective in that way. Dollar lookup is the operator within the MongoDB query language, which enables you to pull data from multiple collections. Think of it like a join in the relational world. Typically, when you embed, data is accessed together. It is faster for reads. Now, there is a chance for slower writes. And when you're referencing, use this for data that is infrequently accessed together. Data that you don't necessarily always access in the same way. Think of it like perhaps you've got a master and a detail screen in your application, and users may rarely navigate from the master to the detail. Maybe you store your detail data in a separate collection. And this is going to be slower for reads because it's going to be multiple reads. Now, how do you know when to do this? I always get this question. How do you know? How do you know when to embed versus reference? This is the master question, the $1 million question, folks. I can't tell you. The answer is I don't know. The answer is that you need to look and do the math. It is physics. You're going to want to look at how your users are accessing the data in your application. And it's kind of a chicken and egg thing where you don't know how your user is going to access the data in your application until you lay it out and actually do it. So sometimes it's a trial and error. Sometimes you make a wager and you lay your data out in one way, and it turns out that it's not efficient. And you got to go back and you modify it. And I'm going to show you how to think about that ahead of time as you develop your data model. Evolving your data model. Imagine day one of your application, you make some assumptions about your data. Let's say you're storing user details in your data. You're going to store the user's name. That's smart. You want your users, you want to be able to identify who your users are. So yeah, let's store your name. That's a great idea. Homer Simpson's your first user. Day two comes along and you're like, wait a minute. I want to be able to sort by user last name. And in order for me to do that, I got in my first data model, I got to like pluck off is it a space? Is there a middle name? I don't know. It's a big mess. I'm sure some of you are nodding because you've done this before, right? Well, you want to break out your last name or your family name. And now that means you're going to change your data model. Okay, so what happens with MongoDB is that you can just change your application to begin writing data. The next time you write data, if you change your application to write an object for name rather than a string for name, is that new documents will have this new data model. And that's wonderful. That's polymorphism. Look at the document on the left and the document on the right. That's polymorphism. Poly is multiple. Morph is shape. Multiple shapes. These two documents had different shapes. Wow, it's amazing that MongoDB can support that, right? What happens to the document that was written on day one when you change your application to write that data in a new format? Nothing, folks. Nothing happens to Homer's document. So that's up to you if you want to go back and evolve your data model. But I would suggest that you start to take a look at writing a version. Now, when you change your application, perhaps you want to create a version tag for your data model so that at any point in time, if you want to do data cleansing or change the previous documents, you're going to want to know what version of the data model you wrote that data out in. So this is how you evolve your data model. There's also schema validation, which I briefly mentioned earlier. You're going to use JSON schema if you want to get very picky about the types of data and the values that get into your database. MongoDB is not stored in JSON. It looks like JSON. It's not actually stored in JSON on disk. It's stored in something called BSON, binary. It's a binary version of JSON. And the reason that we do that is so that we can support true data types. JSON has minimal data type support. BSON supports many different types. So while it looks like JSON, on the end of every key value pair, we store a couple of binary bytes to indicate what actual data type it is. JSON schema lets us validate for the values that are getting into your database what the types and values are. And you can be pretty prescriptive about how you create these schema elements. You can validate only when data is inserted or updated. Okay, you can apply it to new or existing collections, and based on the validation, you can take different actions. You can reject or you can error, and simply warn based on the matching or mismatching of the data coming into your database. Let's take a look at how are we doing on time. 35. I do want to remind folks to stick around as we get toward the end. We're gonna issue a poll, and I really need your help. I need your help to make sure that we improve, and it's going to ask you for a rating. Give us a rating, an honest rating of what you think of the webinar content and how we can improve. So stick around for that. Let's talk about data design patterns. We've got many, and we've got some super bright folks that have written about this, and I'm going to share some URLs with you where you can learn about common design patterns for specific use cases. Polymorphism, I briefly touched on that before. There's a pre-allocation design pattern where, let's say you know the document structure ahead of time, you can use your application to pre-write or pre-fill that document structure. It's called the pre-allocation design pattern. There's a subset which essentially solves the problem of too much data per document. It's going to do a summary of the data being written, and as it's written to your documents, it's going to summarize the data so that it's already pre-calculated. All of these design patterns, there's so many of them, they've all been written about and talked about on our blog, and there's a URL there, mongodb.com/blog. Check that out. There's some great content there, and it's called Building with Patterns. Let's take a look at one of those patterns, the outlier pattern. Imagine you have an application that's managing books, and there's one book written by my brother John. He wrote this book. It's called the MongoDB Aggregation Framework Principles and Examples, and it's available on Amazon. There's a couple of users that have actually bought this. Okay, so maybe 3 or 4 users. If you look at another book, there could be millions of users that have bought the book called Harry Potter: The Next Chapter. You're not going to want to have an array that stores the user ID of every person that purchases that book. Okay, that's going to be, you're going to blow out the size of the document probably because there's so many of them. You may consider, with the outlier pattern, summarizing or keeping just the top or the last number of purchasers of that book, and then include a new key called something like, I don't know, has extras. The name of the key is arbitrary because that's going to be what your application uses to indicate whether or not it needs to fetch an additional document for more details. What we're trying to do is avoid a boundless array or a large document that will that'll cause us problems and be inefficient when we read. So this is called the outlier pattern, and it's quite simple to use. Read further. There are some great articles on this blog. And Daniel Kupal, fabulously brilliant engineer here at MongoDB, and does some of the training and writing about these patterns. So read more about that outlier pattern on our blog. Let's look at some anti-patterns. So avoiding anti-patterns with MongoDB. I mentioned this briefly. Massive arrays. You don't want to have a massive array because of the lookup structure. What has to happen in order for MongoDB to fetch a specific value in an array? That's a decent amount of CPU and search time that it's got to go through. So you want to limit your number of elements in your array. Massive numbers of collections. Now, this happens quite frequently when folks come to us from the relational world and they simply convert tables to collections. You might be thinking, oh, it's going to be easy. I'm just going to convert tables to collections. Not a good idea. You're going to have tons and tons of collections. It's going to be inefficient. You're going to store massive amounts of data, and your application is going to have to join all of that. consider collapsing and embedding where possible. So limiting the number of collections that you have. I mentioned this earlier, unnecessary indexes. It's the same in the relational world. Indexes are costly in terms of writes. When you write data to your database, you need to update your index. So if you're not using the indexes for reads, get rid of them. Bloated documents. So the maximum number of the maximum size of a MongoDB document is 16 megabytes. So you're not going to want to have a document close to 16 megabytes for sure. So you're going to want to consider when you have a document that is on that scale, that's that large, consider breaking it out. Look at whether or not your application is accessing all of that data. Is it truly reading all that data, and is it truly presenting it to a user? If not, then break it out and create a separate collection for that. Separating data that is accessed together. Separating data between different documents and collections that is frequently accessed together. So once again, it all comes down to ensuring that the data that you present to your user is stored together when it's accessed together. And that's our mantra. Take a look at the bloated documents anti-pattern. Now, how can you run into a condition where you've got one document that just has way too much detail in it? Here we've got our movie database, and in it, we've got all this data. We've got really valuable stuff that we're going to need on our application's homepage, right? Probably the title, the year, the plot, maybe the last update, the countries. I don't know if we're going to need that on our front page. Reviews. Do we need reviews on the front page? Maybe the top set of reviews. I don't know if I would want all of the reviews to be stored in this document. Facts about the movie. I don't know that I need those right there. That's probably a second level. And that could be many, especially if it's like a part of a forum or a blog or something like that where people are commenting. So this is pretty crazy. So you're probably going to want to take a look at breaking those facts out into a separate collection, maybe even the reviews, so that you're nice and concise. And again, the anti-mantra is data that will not be accessed together, right? Those facts probably not going to be accessed at the same time as all those other details. Data that will not be accessed together should not be stored together. So the mantra works in both ways. All right. So Schema Advisor, this is great, and especially as it relates to indexes, because indexes are super important. But you may want to make sure you're not creating indexes that you're not using that are superfluous. Schema Advisor automatically recommends improvements to your schema so that it runs better. And these improvements could be like maybe you're accessing your data. What happens if you don't have an index? Anybody know what happens? If I read data from my database and I don't have an index, it's got to do a collection scan, especially if I'm doing a find. If I'm issuing a find, trying to find specific documents that have certain conditions in them. If I don't have an index, there's no B tree created. There's no inverted lookup table that speeds access to those specific documents that I'm after. Then it has to do what's called a collection scan. Very similar to a table scan in the relational world. Collection scans are bad, folks, especially if you have many, many documents. Indexes alleviate the need for collection scan, so you're going to want to create those. The Schema Advisor in MongoDB Atlas will also detect unbounded arrays. It'll also look at the reducing the size of large documents, as well as reducing the times that you need to use $lookup. And as I mentioned previously, $lookup is the operator in the MongoDB query language that enables you to join data from multiple collections. Schema Advisor can be found in MongoDB Atlas under the Performance Advisor tab. It's going to help you create indexes, drop indexes that you don't need, and ultimately improve your schema. All right, folks, we are coming down to the wire. Make sure you get your questions in there. We've got about 10 minutes left. Quiz time. Data that will be accessed together. Let's see it in the, yep, there we go. in the comments. All right, everybody's got this one. We got it. Look at this. I love it. Right on. Yeah, data that will be accessed together should be stored together. Right on. That was D. That's an easy one. Here's a little bit more difficult. What's the name of the MongoDB podcast? All right, come on, folks. Nice. All right. C, the MongoDB podcast is called the MongoDB podcast, available at mongodb.com/podcast. Check that out. Subscribe, like, leave us a comment. Hey, what happens when you change your schema and your application begins to write data in a different shape? What happens to all the previous documents when you modify the data model in MongoDB? Well, we got some. Yeah, pretty clear. Everybody gets this one. Polymorphism rocks. Yeah, nothing happens to those previous documents, folks. You do need to think about writing a version tag when you change your schema in your application so that you can go back and maybe unify the way that the documents are stored. Yep, nothing. Polymorphism rocks. Data that is accessed together should be stored together. All right, so we've got additional resources. We're building with design patterns. Again, you're going to get this in your email on Friday. It'll have links, a summary of the schema design anti-patterns, how to spot them, schema design best practices, some great articles there. Hey, folks, it's survey time. We're going to hang out. We're going to do some questions. We're going to make sure we're getting all of your questions answered. I'm going to take a look at some of these live. How we doing? Joe, Cedric, Diego, we doing okay? Okay. Wow, there's a lot.
We're chugging through the questions, Mike.
Okay, I'm going to start from the bottom and maybe go up.
Good idea.
Yeah. Okay, so is there, similar to SQL, view? Yes, there are views. You can look at tools like Mongoose and like Prisma. These enable you to create schemas and views from within your application. I hope that answered your question. Is it not recommended to have several objects in one document to identify subdocuments, for example? I'm not sure I understand that, but it is separate object IDs. Yeah, I don't know how to answer that one. Joe or Diego, maybe. I don't know. Is it not recommended to have several object IDs?
What's the question?
Is it not recommended to have several object IDs in one document to identify?
You can make more object IDs, but only underscore ID is indexed. So you can put object IDs in any field, but they're only guaranteed to be indexed in underscore ID. So,
okay. Yep.
And object IDs are really just a unique ID. They're guaranteed to be unique across a sharded cluster. So it follows a standard kind of UUID format. There's a standard for that. And so, yeah, you can have them. They just won't be treated specially inside other fields.
Yes. I mean, you could theoretically create your own index on those object IDs in an array, for example. But, yep. Okay, great. Is it possible to customize ID value? Well, you're creating an object ID type, and that's given to you. It is automatically based on certain key values that are like, I think the date salt is in there. You can create your own object ID type, but in terms of the underscore object ID value, you can override it. I don't necessarily think that's a great idea, though. You want it to be unique. Okay. When there is no,
as long as you have a guaranteed primary key, Mike, you can use it. But if you that index is created automatically as a unique index, and so if you don't have a primary key value and you try and insert the same value twice, it will fail on insert with a duplicate key error. So what you want to do is, if you imagine you were building a database of US citizens, we know that their social security number is unique. So you might save yourself an index by putting the social security number into the underscore ID field, and that would save you an index. So lots of people do that, but you must know your primary key will be unique.
Right on. Okay. When there is no index in the collections, we get a warning every time a query is performed. You can turn that down. There is a setting in MongoDB Atlas when you create the cluster. You can actually set it to not warn at all. Um, and there's also a setting at the driver level in your application, so you can ignore those warnings. I would want to take a look at why why you're not using an index, and make sure that you truly don't need one. However, how do I define a bounded array in MongoDB? So bounding an array, this is a great question, Reginaldo. So when you bound an array, this is an application concept. You are going to either, I wonder if you could do it in JSON schema, I don't know, but the way that I typically do it is I do that in my application. I specify in the application, and maybe that's maybe a configuration setting or a .env value that I provide so that it can be changed. But that's going to be logic in your application to bound that array. And there are several patterns that will encourage you to do this. You may want to limit the number of elements in an array to 10, and as your application begins to try to write the 10th, you evaluate some certain condition and either bump off the last in, first out, that type of thing. But that's going to be application logic. When you need to create, update, and the data is duplicated, are there mechanisms for writing data in every occurrence? Or would it just be up to the application to make sure it updates that data? Yeah, so there's no automated trigger mechanism that indicates that you've got duplicated data or anything like that. We are, one of the key concepts is that we alleviate the necessity to create a schema, and this schema that lives separately from the data. But in doing so, we empower the developer to control how the data gets into the database and whether or not data is duplicated and what happens in the case that it is duplicated. That becomes your responsibility, and it is a trade-off for sure. So I hope that answered your question, Josh. Kelvin, can Michael share some concepts about transactions and what kind of recommendation we as developers should be careful when utilizing transactions? So I'd be curious as to why you need transactions if you're effectively laying out your data. There are some conditions that you will need. So MongoDB is fully transaction compliant. You have the ability to create transactions and execute rollbacks, and that's all supported within MongoDB. I think the best thing we could do is probably point you to the documentation to look at those transactions. We fully support ACID transactions as a part of MongoDB. I think that came along around 3.6.4.0 timeframe. Hope that answers it. Adriano, how would indexes work on a polymorphic document where the name field in one document is a string in one? Oh, great question. I don't know how that works. To be honest with you, I'm embarrassed to say, Adriano, I don't know how that works. How would indexes work on a polymorphic document where the name field in one document is a string and in another it is an object? Well, I don't think you would be indexing the object accurately, but I don't know. Joe?
Yeah, it's not one you can answer off the top of your head without knowing the schema design and what you want to do with that data. You would have to do some kind of meta table between the two that does the mapping, or you would have to build something in your code. It's a relatively unusual requirement. I'd love to understand more about what you're trying to do, because often these questions result, I realize my mic is too far away from my mouth. Often these questions result from a desire to do something in MongoDB because you did it that way in relational. And so it's a leap of faith to kind of go, the biggest mistake you can make moving from MongoDB or from relational to MongoDB is go, I'm going to make every table a collection. That's an anti-pattern in MongoDB. Mm-hmm. Typically, it's like a 10-to-1 mapping from tables in relational to collections in MongoDB.
Yeah. Great. Okay, can we get the link to the outlier blog? I won't be able to do that at the moment. Cedric, I'm gonna challenge you, sir. If you can find the MongoDB outlier blog patterns, it's off of mongodb.com/blog. So we'll see if Cedric can find that and put it in the chat. Okay, Mike, I'm running MariaDB. What is the best way to migrate data into? So there's many ways to migrate your data into MongoDB. There's a relational migrator that is brand new, and it's built into MongoDB Atlas. It'll help you migrate the data into, and that's something that I have not personally used just yet. So I'm going to point you to the documentation for that.
The migrator is not actually publicly available to download at the moment.
Okay.
So if you want to do that, you're going to have to contact us, and we do that as a kind of a customer engagement. For now, the simplest way to get your data in is just to do a Mongo dump and then take that data and Mongo import it into MongoDB. That will get you to the situation I talked about, which is a collection per table. But it's a lot easier to muck around with the structure inside MongoDB. And it's the best possible way to learn MongoDB is how do I merge tables into one environment? So that's the starting point. But after that, you've got to get the schema right for an embedded model usually.
Mm-hmm. I will tell you the wrong way, the surefire wrong way is to simply convert your tables to collections, as I mentioned during the webinar. On documentation, stay this patterns. Where can I find more related info? So someone kindly, Gennady, kindly put a link to the outlier, and there are links to the other blogs that are similarly related. So check the chat. Thank you very much, Gennady. That's kind of you to do that. Brian King, data is stored in BSON. Can it be queried in BSON? Well, if you're writing something along the lines of a driver, you can query it directly. It's an open standard. bson.org is where you'll get information on that. Hope that answers your question there. Sridhar, what is the difference between data clean and data cleansing? I have no idea. I don't know what the difference between those two things would be. In the presentation documents, you'll get information about the presentation in your email on Friday. Clean and cleanse. I don't know what that is. How do you apply validation to already existing collections? I don't know.
You can apply the JSON schema and you can select a range of options. You can ask it to tell you to send an error if the documents don't comply with the schema. You can tell it to warn when documents don't comply with the schema, or you can say, ignore the current documents, only apply the schema to new documents which are inserted or updated. So you get a range of options there. I do recommend for people applying schema, JSON schema to a collection that they apply it like in the most promiscuous form possible, which is just work with new documents initially, and then do a warning mode and then do an error mode, and that'll get you where you need to go. It takes a little longer, but it guarantees you don't start pulling your hair out because there's a million documents that aren't complying.
Right on. Thank you, Joe. What is faster in terms of sorting and filtering? Is faster? I don't know. Will it be faster if we take out given, middle, and family at the root of dictionary? I don't know. Faster is a relative term. Really difficult to answer without knowing more details about how you're accessing that data, what you expect to, the volumes of data as well. How do we handle changes on embedded data of your document? If is a category or catalog that is being used in all your documents and you want to change the name or example of that category. So I think I get what you're getting at. This is a common question. If you've got let's say you've got a retail catalog and you change one reference to a catalog item and it's stored throughout your database in other collections, for example. There is no cascading change in MongoDB. You are going to need to maintain those changes. If you change that in one place and it's changed in another, you're going to be responsible for making that change. Now, there are ways to automate this, but it'll be part of your application logic. Let's see. Thanks, Joe. But if I created an index directly on Atlas, then it would be the same. I'm not sure what that means, but yes, indexes created directly on Atlas are implemented in the very same way that indexes you create on an on-prem work. So yes, if you need to normalize entries, how do normalize entries have the same structure? I don't know. Is there a limit in the size of a document? Yes, 16 megabytes. Somebody made a reference in the comments that it's 60, but it's actually 16 megabytes. There are ways to store larger data elements in MongoDB, but that's outside the scope of this call. Do you recommend MongoDB for data warehousing? What? Of course we do. We have a data warehouse built into MongoDB Atlas. It'll assist you in the process of creating a data warehouse. Check out that documentation. With all the real-world problems, does MongoDB have a data that tells you the statistics, what is being used, referencing? Yeah, that's the schema advisor. Will give you those types of details, and there's actually driver level details that you can return on your database to get those types of information. But MongoDB Atlas not only offers the schema advisor, but it also offers a wealth of detail around monitoring. You can go very deep and understand exactly how your application is accessing the data. Folks, we are over time. I hope you filled out the form. I hope you enjoyed this webinar. And I hope you'll join us again. Check out the MongoDB podcast at mongodb.com/podcast. Like, subscribe, give us a comment. Thanks, everybody. Have a great day.